kind of proving a concept that, you can move to more sustainable ways of productive living. But I think it's a good question. I think the answer's still out there in terms of how do we break the cycle.
Thanks very much,
Thank
Catherine.
you.
We better move on. Our next speaker isn't Tim Benton, who sends his apologies. Fortunately for me, he also sent slides. And fortunately for me, I acted as review editor on Tim's chapter, which is chapter 5. Being Tim's not here, Tim is from Chatham House and does lots of good work and is also involved partly still at the University of Leeds. And then I'll take the opportunity to do what I forgot to do at the start and tell you who I am. I'm Andy Challoner from the University of Leeds. I'm a chair of climate impacts with, it says here, 20 years experience in modelling food security, leader and founding member of the Climate Impacts Group, which currently has 15 members, and I've written for the IPCC and the UK Climate Change Risk Assessment. As I say, this is Tim's talk, which I will attempt to do justice to. So climate change, diets and land. Unsurprised, I've declared my bias at the start, haven't I? I mean, I think there's some really exciting stuff in here. So food security, first of all, what does it mean? Some definitions to start off with. So food security is a situation that exists when all people at all times have physical, social and economic access to sufficient, safe and nutritious food that meets their dietary needs and food preferences for an active and healthy life. There's been a lot in the literature back and forth and amongst different organisations about exactly what constitutes food security, and this definition kind of does capture it all kind of in that one very long, albeit very long sentence. But the point here is it's multifaceted. It's not just are we producing enough food. In fact, that may not even be the main issue with food security in any one place and time. So food security is about sustainably supplying nutritious diets, not simply growing more calories. The food system, I said a bit about this at the start, so it's all the elements, environment, people, inputs, processes, infrastructures, institutions, etc., and activities that relate to production, processing, distribution, preparation and consumption of food, and the output of these activities, including socioeconomic and environmental outcomes. So both of these things are probably more complex than you would think at first sight. That's what those two, I won't test you on what those definitions are afterwards. But if you walk away with the sense that actually there seems to be a lot of stuff involved in there, then you'll get full marks in my book. So food security arises as an outcome of the food system. It's not simply that kind of you can map directly to agriculture. The food system connects supply and demand. So it inherently is about both supply and demand and the interconnections between those. And you need to look at both of those. And traditionally it's the production side, and I've spent many years working on the production side and what climate change means for that, but there comes a point we have to recognise, okay, that's an important component, but it may not always be the main component. Climate change, climate change and how food systems are affected by climate change. So again, there's a long list here through changing climates. Where can crops and livestock grow? Where do pests and diseases live? What are the matches and mismatches between plants and their pollinators? What about effects on crop quality? So sugar levels and nutritional quality, spoilage of stored food, and also through changing weather, particularly variability, extremes and predictability. So drought and heat affects plants, livestock. Extreme precipitation can destroy crops. Unseasonable weather can disrupt development, so strong winds removing flowers from fruit trees, for example. And through disrupting supply chains by affecting infrastructure and thus availability. So Tim and I were both involved and are involved in the current UK climate change risk assessment on the international dimensions of climate change, so all the climate change abroad that affects the UK, and a lot of these issues of kind of supply chain effects and food system effects are kind of documented in that UK CCRA climate change risk assessment chapter as well, of course, as in this report. And also food systems are affected by climate change through changes in basic biology. So the CO2 fertilization effect and changing the way plants allocate resources. So to growth versus reproduction changes the nutrient content as well as just that primary sort of elevated CO2 effect. So lots of these sort of direct and indirect ways in which climate change affects food systems. And Tim says of these perhaps the rising incidence of extremes will have the largest impact. So there's you can see the various extremes that Tim's put, historical extreme events that Tim's put on these slides. And I think that's right. There are a whole range of extreme events that have had an impact, and future increasing incidence of extremes will also be important. I would just add that actually some of the slower changes can be really important depending on the background state of society in other parts of the food system. Because there's already evidence, for example, that climate change is outpacing the breeding of new varieties of crops in Africa, of maize crops. And that's simply due to the slow increase in mean temperature, but it's the fact that the breeding cycles in Africa, the crop breeding cycles, pre-breeding, breeding, getting seed varieties out into farmers' fields, that can be 20 years. By the time that 20 years has elapsed, you're in a warmer temperature than you were when you were breeding the crops, and those seeds are out of date, and you get a few percent decrease in yield. So climate change, even that gradual change, is already outpacing in Africa crop breeding. That's not so much the case further north. But I think Tim's right that the extreme events are, in broad sense, overall the kind of headline. So food, land and climate, this is where it gets really interesting. We've already heard about a lot about land use and the various different ways in which we manage and use land. And here are some figures of global land. So total habitable land, 10.4 billion hectares, of which we use 1.5 billion hectares for crops, 3.3 billion hectares, twice that, more than twice that for grazing, a few million hectares for managed land, managed forest, 3.7 billion hectares for natural forest, and just for scale, Spain is about 50 million hectares. So you can see that we use a large part of our land for grazing, for crops, for producing food, and obviously large areas of natural forest as well. About a quarter of our ice-free land is degraded, and we've just heard more detail on that. There's a whole bunch of other statistics on here, not sure how much I have time to go through. Let me pick some out. 60 to 100% more food by 2050 if you think about growing populations, unless we have a dietary change perhaps, which we'll talk about. We also want to use our land for bioenergy, of course, so renewables typically 10 to 3,000 times more land intensive, and 115 mega hectares of new land for biomaterials and bioeconomy by 2050. And of course we need land for BECCS, for bioenergy, carbon capture and storage. So this is another way of highlighting this issue of there's only so much land, there's no more going to be made, so we need to be very wise in how we use it. Climate change is already affecting food, disrupting agriculture through extreme events and through infrastructure. I won't dwell on that. One interesting area that both Tim and I have worked on are some of the interactions between these extreme events and how they affect agricultural production, and the way in which conceptually this came out in the UK climate change risk assessment, the way in which weather shocks can interact through internal feedback, speculation, stock levels, trade policy. So simple example, wheat harvest failure in Russia followed by an export ban, which drives the price of wheat up. It's not that there's not enough wheat anymore, it's the response of the system to that. And the question is, are we going to have problems where we get into a situation where there are kind of feedbacks within that system, that sort of food, socio-economic, economic system. So price spikes and price volatility affecting speculation, which affects markets and policies and also the broader, obviously, political kind of agenda and what happens with international trade. One can think post-Brexit and think about what America is choosing to do about trade. And all of these things will interact, and probably interact also with shocks from other sectors, such as oil and biofuels. So there's some real potential for big shocks to be emerging. Agriculture and food affect climate, and we've heard already about this, the large role of agriculture in emissions, so I won't talk through that slide. This, thanks Tim, can you see that? I can't see that. If I use manual zoom, maybe I would, but basically making no, let's leave that one. So here's the real, this is nice. So key message one. This is a really interesting thing, let's say, but to me one of the most interesting things to come out of this chapter. It's some real detail on hammering out the numbers associated with demand side mitigation, dietary choices. So what's the mitigation potential of a vegan diet? You know, the highest of all of these that have been looked at. What are the other ones that have been looked at? Various kind of flexitarian, fish and chipper type options. Meat, seafood once a month is the vegetarian definition. Flexitarian, limited meat and dairy. Healthy diet, limited sugar, meat and dairy. But you get the idea. Pescatarian, focused a bit more on fish. But the point is there's some high, so this is grams of CO2 equivalent, a gigaton CO2 equivalent per year, going up to about 8. So some serious potential there. I've done a bad job of keeping the time. I want to make sure I leave time for at least one question. But this is really the other part of that puzzle. So we change our diet and the planet gets better. Great. What happens if we change our diet along those lines? Better for us as well, right? So here's the Harvard healthy eating plate model. I've got 2 small children. Their plates look nothing like this, but anyway, half fruit and vegetable, about a quarter cereals and starches, oils and fats 4%, meat and alternatives 17%. What are we actually eating? You can work this out. You look at the FAO and what are we producing, right? Cereals and starches, nearly double what the plate should be. Fruit and veg, less than half what that should be. More oils and fats, and a lot more sugar. We already know that. So, and I think to some extent this was kind of known already, but this chapter in particular pulls this together in such a nice and quantitative way. Oh, good, yes, so that's been said. So nets and BECs are important, and I don't need to talk about Trump. Wow, thanks again, Tim. Fantastic. This is really nice. This is different response options, and I won't talk them through, but this is where the detail in this chapter is really nice. Different response options, starting at the top with agricultural food productivity, agroforestry, a whole bunch of different things we can do, assessed according to what the potential is. And blue is high, and then there's confidence letters, and this is my point about the confidence that we have in our answers needs to increase, and we need the methods to be able to do that. But the blue, so we've highlighted the areas where there's real potential, and food production, food productivity really being one of them. So hopefully not, oh wow, that's even worse. There's no silver bullet, I agree with that. I'll leave some discussion points for you to just look at while I say, I did ask the speakers if they wanted to reflect on what the kind of big steps forward of the report and being involved in the report were, and both Tim and I kind of agreed that really it's the sheer scope of bringing together of all of these pieces of information in all these areas of work, and I learned a lot just by being review editor, so to me that was a really big part of it. Hopefully you've had a chance to scan that while I've been saying those last words, and hopefully if Pete tells me so, then there will be time for questions. How have I gone from when you said 10 minutes? There we go. So, thanks, Pete. I did ask for your honesty. So time for one question. Yeah.
Sorry, how do you plan to increase food productivity? That seemed to be the biggest change on that last slide.
That was more the potential for food production, food productivity systems to contribute to mitigation. So it's more how it's not so much that food productivity needs to increase. That is part of the challenge, but it's probably not the greatest part of the challenge. The greatest part of the challenge is how to do that in what has become termed a climate smart way, which means whilst essentially reducing emissions. And that actually is it's quite tricky. One of the reasons it's very tricky is because it's very difficult to measure just how climate smart you're being, what the emissions are associated with a particular production system. But you have given me the opportunity to say, there's a paper from a PhD student of mine and myself out last week just on that. What are these metrics for climate smart agriculture? How do we know how well we're doing? We haven't really started to measure that until recently, so that's starting to happen now. Our next speaker, thank you, Pete, for getting up promptly and queuing up, is Pete Smith. Pete is a professor at the University of Aberdeen, who, sorry, I do know you are, Pete. I just want to say sensible things about you. And you sent a succinct biog, which is always good. Professor of Soils and Global Climate Change at the Institute of Biological and Environmental Sciences at the University of Aberdeen, and the Science Director of the Scottish Climate Change Centre for Expertise. Okay, you ready? Right. I will do that, slightly cheeky, but being opportunistic. But yes, come and poke me when you're ready. Time for another question.
Has the IPCC covered regenerative agriculture?
Yes. Yes, but I don't know much about that aspect of it, to be honest. But I know it's there in the report, and I can't say anything much more intelligent than that, I'm afraid. Yeah. Yes. Oh, thanks, Joe. Yeah. Please do.
Yeah, I'm not even still wearing another mic. It's just me and mics. Yeah. There's all these sort of different terms for sustainable agriculture, climate smart agriculture, regenerative agriculture. But what the chapter really looks at is all those sort of different processes and the actual interventions you could do. So regenerative agriculture is a term that encompasses many, many different things, but some of those specifics are really looked at in the chapter. In chapter 5.
Chapter 5. I think there was one more gentleman behind yet.
I'm female.
Oh, sorry about that. My eyesight isn't very good. That is actually
that's right. Firstly, how does the work on agriculture and changing land use systems overlap with the work on restoration for biodiversity? You know, the IPBES work to ensure that we have ecosystems for species, and also, what's the window for error? I mean, one of the things that always strikes me about the IPCC and a lot of the science communities, we just need to do this, this and this. And I'm from a law and policy background, and I know that this and this just doesn't happen that easily. So the window for error, the window for failure, seems to me to be the biggest problem that we face.
Yeah, so integration of IPCC and IPBES, yes, some, but I think really the whole community is only just starting to sort of integrate even across working groups 1, 2 and 3. I'm going to cut my answer short for 2 reasons. 1, because of time, and 2, because it was a difficult question. And introduce Pete, who I've actually already introduced, so without further ado, thanks, Pete.
Thank you, Andy. Cheers. So I was the convening lead author of the Chapter 6, which is the one that tried to integrate all the stuff that you've heard already. So the desertification,